Welcome everyone to this session dedicated to the standardization and development of the Open Neural Network Exchange. This presentation will be delivered by Andreas Filner, and according to our agenda, we'll receive information about this open source framework, which is designed to be able to interoperate machine learning models across various artificial intelligence tools and platforms. Also, this seminar will provide an insight about the use of this open standard within space COE. So this activity is partially covered by the activity by space and included in our Center of Excellence initiative. The tutor is Andreas Filner, who studied physics at the University of Regensburg and obtained his PhD in biomedical imaging in Berlin. He works as project manager and software engineer for machine learning in pre-development with a focus of transferring ideas in the field of artificial intelligence to working products and a mechanical engineering company in industry. That means that he's, of course, giving an insight as a scientist, as an expert, but also with a more, let's say, tangible point of view, not solely from an academic point of view. So he's interested in the open source for AI as a former elected member of the Open Neural Network Exchange Steering Committee. He's committed to establish this standard. So he is the right person to give us an insight. So Andreas, the floor is yours. I'm happy to stop sharing and give you the lead.
Okay, good start. Okay, so yes, like Marisa said, I'm deeply involved into the ONNX project. I was a former member of the steering committee, and currently I'm a SIG lead for the architecture and infrastructure parts. Is it somehow an overview talk? I have a lot of slides, so I don't dive deep, but if you have questions, we can talk about it afterwards, or you can send me a message by email, LinkedIn, or yeah, we'll find some way to interact. Why doesn't it work? Okay, so I will talk how do we use ONNX in space? Why do we want to use it? So, and what is the motivation for ONNX? What is ONNX? The technical design of ONNX, how to get an ONNX model, how to run a model, what is the ONNX community, how is, what different groups are there, examples for tools from the ONNX community, and why is it so important that ONNX is a part of the Linux Foundation? So you see here, I want to cover a lot of topics, so let's get started. So ONNX in space, how do we handle, why do we need ONNX? Yes, what is our goal in general? We want to make some astrophysical simulations for the exascale computing. So we have our challenges. We have a lot of data, really a large size, petabytes of data. How do we handle this data? And now it's very complicated. We cannot store all the data on our local machine. So now we try to find some machine learning components so you can play with the data, that you can interact with the data. And now one central idea is you need a really efficient workflow. And as you see here, a lot of points are parts of the workflow. You have to do some training, some pre-processing. You need some formats, how you store your data. And when you have done your training, you have to store somehow your model. And then it's a question, where do you execute your model? It could be as a web service. It could be on a smartphone, at your PC, at a lot of different parts. Sorry. So you need to have some common format for storing your machine learning model. And I will show you how it's maybe not suitable to directly use your development workflow. And one where you can directly see how we use ONNX up to now, or is a space where you directly can interact with your data. So what is the motivation for your standard? Now, in industry, for example, you want to deploy your machine learning model to different factories. So if you want to FPGA, GPU, CPU, or neural processing units. And yes, in your development or at university, you train your model with, for example, with PyTorch, with TensorFlow, and so on. Here you can update maybe you can take every new version you want to have. But now when you have to deploy it, it's a factory, you cannot update the whole day or maybe only one time a year or two times or every 2 years your model. So it's not possible to use from a new TensorFlow version, for example, for an 3 years old OpenVINO version, you don't have a direct path to convert it. But what do we want? We want to use as a tool we want. For example, maybe we are interested in using PyTorch because there's a lot of power in the development, or in TensorFlow because we like specific packages. And so now we have the freedom to use the tool of our choice, and we can bring it directly to these different deployment targets. And also as a deployment of manufacturer, when you create some specific device, you don't have to support PyTorch, TensorFlow, and Keras. It's possible to just use ONNX for that purpose. So what are common problems for ML productivity? The inference latency is often too high to put into production. So we have to use some optimizations of the graph. Yes, quite often we train in Python our machine learning model, PyTorch, TensorFlow, just to name two of them, but we cannot bring, or quite often it's not reasonable to bring Python into production. So we have to bring it to some C#, C++, or Java applications. So it's not so easy with a lot of different training frameworks. Then our model should run on edge on IoT devices, but also in the cloud. As I said, should run on different hardware or operating systems. And yes, different people like to train their model on different training frameworks. So what is now ONNX? ONNX is now stands for Open Neural Network Exchange. It's an open specification which consists of the 3 components. Some graph model. Here I displayed some graph definition of standard types in 4 and 8, float 16, float 32. And some definition of built-in operators, like some ReLU, some convolution operator, and so on. These are now the 3 parts where one tries to find some standard. So ONNX stores the data in a format called protobuf. This is some message format developed by Google. And each computation data flow is structured in a list of nodes that form an acyclic graph. Here you can see there's also some text version of protobuf, where you can see here's some input node 111 and 109. So we have 2 inputs and 1 output from some for the add operator, and the output for that we use some ReLU. This is some text presentation, and we have here some operators. And of course, we can add some metadata to the ONNX format too. There are a lot of different tools how we can interact with our graph, see what's going on there. One really popular app is Netron, where you can see here what's inside your ONNX model. But Netron is not only for ONNX, it's also for PyTorch, TensorFlow, and on. And so you can investigate what are the name of your layers. If you want to cut, for example, your model into different parts, just extract some specific parts of the model. So ONNX in general should support deep neural networks, but also traditional machine learning. I would say the focus is deep neural networks, but also a lot of parts from scikit-learn can be exported to ONNX. It's somehow backward compatible. I would say backward compatibility is a large problem of the other from the training framework. So you don't often get backward compatibility. I will show you a graph about that later. And it's as we use protobuf, it's a compact and cross-platform representation for ONNX. What is ONNX not? It's not about some graph execution implementations that belongs to so the hardware companies for the GPUs or the Intel CPUs, for example, and for the operator, which operators, for example, can be fused. So which operators are added to the standard? So I would say it's not a goal to add every new operator to the standard. When it should be somehow some limited list, some minimal minimal set of functions or operators. So the operator should be included into more training frameworks. For example, it should be maybe used in popular paper or popular solutions. So one have to really show that this operator is really needed from a larger community and give some benefit. And at the moment, there's a release 1.18 is coming probably end of next month, and there are a lot of operators included, which are, for example, now important for some LLMs. And I took some graph from the PyTorch website. Also, PyTorch is also a project of the Linux Foundation now, and you see here, PyTorch has over 1,200 operators and quite a lot of overloads. There are quite a lot of operators which just dealing with convolutions, for example. And PyTorch started also some way of somehow cleaning up their large amount of operators in order they define some primary operators and 18 operators. So it's also some objective of PyTorch to get some standard or minimized set of operators. And I would say PyTorch and ONNX greatly interact each other's development. So now, how do we define an ONNX operator? It's defined by the name, the domain, and the version. And we have some core ops, which should be supported by all ONNX compatible products. And yes, you cannot further decompose the ONNX operator anymore. And currently, we only have 180 ops in the domain and 18 in for machine learning. And if you need some special operators, you can also define these operators, which are not part of the standard, but if you need them, there are some possibilities to add them in order to get your model supported. Here I added a list of the different operators. For example, we have some convolution operators, some transpose convolutions, some dequantize linear operator, depth of space, and here you see different versions from the offset 1, 11, 22, and there's a defined way to use the older version. When you have the newer ONNX model with newer offset versions, how to convert or how to get it run in an older version. And this backward compatibility does not exist in such a way in TensorFlow or PyTorch, for example. So how do we get now an ONNX model? Maybe the most popular way, in my opinion, is by model conversion. PyTorch, for example, does really work great for that. You have some, I would say, old, the current JIT export, which creates some graph which you can use, and some newer dynamo export, which works quite well. And so also Microsoft contributes a lot to it. And also for TensorFlow or Keras, there's some exporter. And here on the right side, you see how you convert your TensorFlow model. In TensorFlow, for example, you have the saved model format or frozen protobuf, or now some Keras 3. And this you can convert to ONNX with this defined standard by, for example, using these command line arguments. And for scikit-learn, it's in general written here, and for PyTorch, you convert it like on the right here. Of course, you can have a lot of different parameters more, how to set the names of your model if you want to have some static static shapes or dynamic shapes, and a lot of more. But also you can also get your model from Hugging Face, for example, or the ONNX model. So, and there you can, would say, for so most of the popular large language models, you can also find ONNX versions of it. So how to execute a model? So here I said ONNX is some open standard. It's under the Linux Foundation. It's Apache 2 license. And now I go to one example of a product. So it's not from ONNXRuntime. It's a Microsoft tool. It's a product of Microsoft. It's not part of the ONNX standard, but they are using ONNX quite heavily and are contributing to ONNX. So, but I could have also mentioned OpenVINO from Intel or OpenCV to explain how ONNX could be used. So similar graphic we also had. Microsoft additionally have some model optimization toolkit, but also Intel, AMD, they have different, or in ONNX, the community itself, there's some machine learning model fine-tuning tool of the conversion, quantization to lower precision, FP16, or for large language model, even lower. So as I said, this is somehow architecture dependent or where you want your model to be run. So you can, this is some optimization, which can you also save in the ONNX standard and then use ONNXRuntime. And ONNXRuntime is a product which you can run locally, but also on the web and at different platforms. Here, as I said, it's a cross-platform inference and training machine learning accelerator. And you see here, it's available for Windows, Linux, Mac, Android, iOS, web browser, different languages from Python, C++, and also Rust exists. And you can directly integrate the hardware acceleration tools. For example, OpenVINO from Intel, Rakuda from NVIDIA. So you don't lose speed by using that tool. So what is so interesting, just to summarize, ONNXRuntime supports a full ONNX machine learning stack. It supports CPU, GPU, NPUs, and the API is quite similar. So you can use now, OpenVINO, Intel CPUs or NVIDIA GPUs without learning somehow a new API because it's somehow covered by the ONNXRuntime syntax. It's cross-platform, and this is some extensional architecture. As you have seen, we can integrate different execution providers like OpenVINO or Intel or CUDA or TVM, Apache TVM, and so on. So what optimization are ONNXRuntime providing? Some graph transformation, some constant folding, redundant nodes are reduced. Then it's working for parallelization. And you also see some list from Qualcomm, AMD, Intel, what can be used within ONNXRuntime. So it's also quite interesting for some independent hardware vendors that you can integrate your own hardware into ONNXRuntime, and so you get, I would say, you don't have to bring your own SDK or way of how to work with your hardware product. You just can use ONNXRuntime and you write your plugin that it can be used within that. And of course, nowadays, generative AI, large language models are quite popular, and ONNXRuntime also supports these. And here it would, for example, look for classical deep learning or machine learning part where you just have one model and one input size, and might be an image or some table data, And this is a way how you would interact with ONNXRuntime when you would have some interaction by writing prompts and so on. So I know this was quite an overview about ONNXRuntime, but if you want to know more about really the technical details, how they are proceeded with the different hardware layers, how the different optimization stuff works within ONNXRuntime, there is some online community meetups. For example, the last was now about a year ago. You can find it at this YouTube address, and there you can really deep dives into the newest technical functions of this product. Now a bit less from about the product from Microsoft ONNXRuntime, about the ONNX community. How is ONNX developed, and who are the key players in that? So ONNX is really a community project. It has open governance, and the steering committee, you see a lot of popular companies here from Microsoft, IBM, NVIDIA, Intel, and AMD work together to strengthen this standard. And they are not in the steering committee because they are from these big companies. They are elected by the whole community. These 5 people. Each year there's some steering committee elections. This steering committee gives a roadmap or the direction of the standard. But I would say the day-to-day work is done in the special interest groups. There exists, for example, one special interest group for architecture, for infrastructure, or for the converters, compilers, which operators should be, for example, included. How should the optimization work or some models do? These are the special intergroups, and from time to time there are coming new working groups. And when the project is finished or the work which should be done, it's a working group, then they don't exist anymore. For example, one problem in this machine learning context is, for example, in pre-processing, quite often some model does not include the pre-processing steps. So maybe you have your model, and then you have to do some transformation, scaling, binarizing, thresholding, some before or also afterwards. And these are they made some progress to integrate the pre-processing and the post-processing steps also into the model. This is not common so far. Another working group is a safety-related profile. It's when you, for example, want to use this model in aeronautics, in the aviation industry, or in the space industry, you have to be more strict about what's going on. If it's that the model is really doing that what you're thinking that it's doing, and this you have to prove with some formal methods. And this working group started last year, and we have another working group for multi-device. Just to give an example for the safety-related profile, for the aeronautical domain, we need to demonstrate that the model is correctly implemented and executed on the target hardware. And therefore, we need some unambiguous description of the ML model. And this is some ongoing work now where we really have to clarify from each operator what does it really do? Is it really clear? Is there only way of implementation that we can prove it also afterwards? And from the file format and the graph semantics. So it should be binary proved at the end. So it's not this machine learning is not used in the aeronautical domain yet, but this could be a way to bring this also in this field. So what else? As I said, ONNX is a community meetup. The technical decisions are made by the steering committee, by the SIX and the working groups. We have some Slack channel, mailing list. Every year there's some community meetup. The next is in April, and you can register soon and can all the videos find at the YouTube web page. All the meetings of ONNX are open to everyone, from the steering committee, from the SIG operators, from the models or the optimization meeting. So feel free to join and discuss your needs or just show your interest. Then how do we decide in which directions should ONNX project go? There is every year or every 2 years, there's a new roadmap process. And for example, in the 2 years ago, there was quite a lot of interest in modern operators, for example, for graph neural networks or the transformer. Then we are going lower to EBOS floating point 8 and how to support sparse tensors, but is also there's some need for web AI GPU support or some multi-head attention. You can find the list on the web page. So there's a broad support from the community for ONNX. And every about 4 to 6 months, there's a new ONNX release. And the last releases are going a bit more into the TinyML or somehow edge AI communities. So we support smaller data types, for example, int4 and float 8. And for better performance and broader device support. And as I said, next month you could expect a new release with also Python 3.9 support. And these are new operators which will be included. So what does it mean? We say it's an open standard. So ONNX is not a standard it's not developed by a traditional standardization organization like ISO or IEEE. Instead, it's a standard by, I've written here, Microsoft and Facebook decided that it should not be closed company project, that it should be developed by a community of collaborators. So they were looking for some neutral home for this project. And so they find the LFI and Data Foundation, which is an initiative under the Linux Foundation. And this is some neutral platform that brings together and accelerates various projects focused on AI, machine learning, deep learning, and data. Now I will give you some introduction to the Linux Foundation. Probably all of you have heard about the Linux Foundation. It's really a large foundation, and there are a lot of projects part of this foundation. This LFI and Data is one part of this foundation, but there are a lot of other parts. For example, the Cloud Native Foundation is a project from the Linux Foundation. Kubernetes is, for example, part of that, or there exists this Open SSF for a security foundation. So this cover a lot of parts in the software. And what is somehow the vision or some part from the Linux Foundation to say some software is too important to be tied to a single host and controlled by a single company. I would say that's also true for some standards. The standard cannot be set by a single company, or maybe should not set by a single company. So LFIA writes on the slides, it's a neutral facilitator and gives experience and credibility to the project and initiatives. And so it's some, I would say, some neutral vendor, neutral place to bring together different developers, different people have different interests in the whole machine learning workflow. And why does neutrality matters? Because the biggest reason I would say is somehow trust. The decisions are somehow unbiased. What you see in the steering committee from ONNX, for example, so it says NVIDIA, Intel, Microsoft, they are competitors in a lot of different fields. So they have to bring some reasonable standard for that. So there's no And also for other companies, it's now safe to invest R&D budget for into the standard because they know they can use it afterwards. So there's no license change because it's not controlled by a single company. And so trust is an immensely valuable asset. It's for the participant required to make a durable strategic commitments. And it's also, if you, for example, the academic community has some special interests or some budget to spend on, then it could be developed within a set standard. It's not so easy, for example, with some commercial tool. But here one could work together. Yeah, the mission of the LFI and data community is to build and support an open AI community and drive open source innovation in the AI and data domains by enabling collaboration, sharing best practices, supporting efforts, and the creation of new opportunities for all the members of the community. So maybe now I want to give you some an overview about some projects which are hosted by LFI and data. For example, when you look here, for example, Flight, some workflow orchestration tool, which we also use. It hits for orchestrating our workflows. But also other popular tools are here, for example, Horobot for accelerating your machine learning workflow, or some maybe to highlight the Open Model Initiative. Nowadays, everyone writes their new LLM is somehow open, but what does open mean? Is the model architecture open? Are the weights open? Is it somehow explained what I can do, how the training was processed? And the Open Model Initiative gives some structure into this open washing, because not every model which is said to be open is really open and can be used for different purposes. And so this LFI data has some growing ecosystem. A lot of more companies or projects wants to join to this project. There's some overview dashboard for the different parts of the machine learning workflow. And what do these projects all in common? Yeah, there's in this software engineering or software machine learning, there are more parts to consider than just coding. For example, we have how to manage also project assets, some governance challenges, and the products are highly developed in a highly specialized way. We don't know how to handle license requirements or where to push our wheels, how to adopt to so the license, copyrights, and a lot of stuff like that is handled by the Linux foundations. So it's like a safe haven for managing technical and non-technical assets. And there is, it helps to minimize the fragmentations by bringing the different people together, the different projects, how they could better interact and how they could better integrate. And I would say this work is done in the technical advisory committee, where the different companies and projects come together and discuss how to better align the different projects, what is the need of the project, and how they can help each other. And also in this LFI data, it's not only the single projects. There's also some community for data operation, machine learning, ops, for security, but also responsible and trusted AI. And so there's a really great interaction between the different projects and the people from the different committees here. So that was my last slide. So I'm happy to hear questions, and let's discuss.
So thank you very much, Andreas. Let's see if someone is willing to break the ice. I have just a curiosity, not a real question, because I'm not a technician. So for me, it's difficult to have a technical question for you, Andreas. But in the end, I've realized that this is really a huge and transversal project. How many people are really providing support and contributing to this initiative? Because of course, considering also the Linux Foundation, all this work. So it's something really huge. Can you quantify some?
I would say it's really hard to say, because the one is really the ONNX standard and the tools around it. If you're happy with the standard, you are not, you don't have to interact with the people who are really working on the core of the standard. So if you're just using it, you probably you don't have problems, so you don't have to interact to integrate. But Microsoft is ONNXRuntimes or parts of it using it on all their products. If you have some AI assistant at your PC, you have ONNXRuntime or something like that. So it's really a lot of people working on that. And also there's a big support from NVIDIA. I know only the people who are directly dealing with the core of the standard. Of course, different people from Microsoft, they send me slides from the Linux foundations, but a lot of products are based on that standard. And of course, Sarah, I don't know who is using ONNX in what way, but I would say from the core, I know about 50, 100 names which are working on as a main repository for standard, but there are also some tools how you can make a deep dive into your model, where you see which operators are used, how much time or how much flops is used. So from time to time, there are some projects spanned to the ONNX community. For example, AMD spans some project Digest AI, where you can directly interact with your model and see what's in your model, or Intel spans some projects, neural compressor, which is also for ONNX and ONNX based. So I would say I see only the tip of the iceberg who is using that.
Yes, because especially if we distinguish between those that are really, as you said, use the standards and are happy with it, and those that work in improving this. So it's really a huge community, considering the two sides of the.
I would say one really, it's quite interesting to see when a new community starts being interested in ONNX. For example, now this safety community is somehow a new community now, and now you realize how many different companies from France or Germany are really interested in bringing ONNX in this specific part to the next level. But when the people are happy with the standards, so there is not so much need to interact with them, with the standards.
Sure. Thanks for this insight. I see people thanking you for the presentation, for the talk. Let me thank you, Andreas, that much for this presentation and for sharing his experience and his really enthusiasm on this topic. Thank you all the participants that have been attending this webinar. We'll keep on our activity in disseminating space activities, so just stay tuned with us, because of course more initiatives are coming. And thank you once again. It has been a pleasure.
Thank you for inviting me.
Bye, everyone.